All right. So we got theorem 510. If one side of a triangle is longer than another side, then the angle opposite the longer side is larger than the angle opposite the shorter side. So basically, the longer the side is, the bigger the angle is that is opposite that side. Which should make sense, because if I have this angle here at B to be open wide enough for 7, that angle has to open bigger than this angle C has to open up to reach out and open up for 5. Right? So the biggest side is going to be across from the biggest angle, and the smallest side is going to be across from the smallest angle. All right, theorem 511, it's kind of just the reverse of, or the converse of 510. If one angle of a triangle is larger than another angle, then the side opposite the larger angle is longer than the side opposite the smaller angle. So the bigger the angle is, the larger the side is opposite that angle. So you could always put the sides in order in length based on the sizes of the angles. In theorem 512, the exterior angle inequality, the measure of an exterior angle of a triangle is greater than the measure of either of the two non-adjacent interior angles. So this measure of angle 1 is going to be greater than angle A, and the measure of angle 1 is also going to be greater than the measure of angle B. Which should make sense, because we learned when we first learned about exterior angles that this exterior angle is equal to A and B added together. Right? The two non-adjacent interior angles added together equals this one. So this one by itself, this exterior angle, should always be bigger than either one of them by themselves. All right, and then theorem 513, triangle inequality, the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So if I take any two side lengths and add them together, that sum should be greater than the length of the third side. If it's not, then you don't have a triangle. Questions on any of those? All right, so write the measures in the triangles in order from least to greatest. All right, so if we look at what they're giving us the angles measures. Right? So if I look at the angles, we put those in order from least to greatest. 23 is the smallest one, and it's less than 46, which is less than 111. Right? So putting the numbers in order, that means that the measure of angle A is less than the measure of angle C is less than the measure of angle B. And then when we know what the order of the angles, then we can also put the sides in order. So the smallest angle is angle A. So the smallest side is going to be straight across from angle A, which is side CB. So the length of CB is going to be less than. The next one is angle C in order. So from angle C, opposite it is side BA. So BA would be the next biggest side. And then the largest angle, angle B, the side opposite is CA. So CA is the largest side. All right, so that was using the angles to eventually put the sides in order. So the next one, we're going to use the sides and put the angles in order, right? So we look at the side lengths here. TU is 7, which is the smallest side. So that's going to be less than, the next one is 10, UV. And that's less than 11. So for the sides, 7 represents UT, 10 represents UV, and 11 represents TV. And then from there, UT being the smallest here, the angle that would be smallest is straight across from that, which is angle V. So measure angle V is going to be less than, the next bigger side is UV, and straight across from it is angle T. So angle T would be the next one. Then lastly, TV is the largest side, which is straight across from angle U. All right. Questions on those? The largest side is always across from the largest angle. The smallest side is always across from the smallest angle, and vice versa. The largest angle is across from the longest side, and the smallest angle is across from the smallest side. All right, the figure below shows the side view of an Adirondack chair. In the figure, JL is congruent to LK, and the length of JK is less than the length of JL. What can you conclude about the angles in triangle JKL? So we got this triangle here, JKL. Says that JL and LK are congruent, and that the length of JK is less than the length of JL, which would also mean that if JL and LK are the same, that if JK is less than JL, then it's also less than LK. So from this, it wants to know what we can conclude about the angles. So we know if JL and LK are the same, they're both going to be congruent to each other, and their angles opposite them will be congruent as well. All right, so angle K should be congruent to angle J, or the measure of angle K is going to equal the measure of angle J. And then, since we know that JK is smaller than JL and KL, then JK being across from angle L is going to be smaller than both of these angles, right? So I can say that the measure of angle L is less than the measure of angle J, and the measure of angle L is less than the measure of angle K. So K and J are the same, and L is less than both of the other angles. Questions there, anybody? All right, determine if a triangle with the given side lengths is possible. All right, so this kind of goes back to that last theorem we were given. It says that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So if you have side lengths that if I add two of them together, they're not bigger than one of the other sides, then it's not going to make a triangle. So this one, if I look at 3, 3, and 8, if I add 3 plus 3, that needs to be greater than 8, right? Any two sides added together have to be greater than the third side, which if I add 3 and 3, I get 6. So is 6 greater than 8? It's not, right? So those two sides added together are not greater than the third side. So that means that that's not a triangle. Which should make a little bit of sense, because if we illustrate that, let's see. I have I have two 3-centimeter lengths, and then I have an 8-centimeter length. If I try to make a triangle out of those, that's not going to work very good, because two 3-centimeter lengths, even laid flat on the 8, are not going to close, right? And so you're not going to be able to make an angle with them, and those close up the triangle. So then the next one, 6 centimeters, 6 centimeters, and 12 centimeters. So, and when we start checking these, we always add the two smallest ones together to be bigger than the biggest one, because if the biggest one plus any of the small ones will be bigger than the small ones. But so 6 plus 6 would have to be greater than 12, which I get 6 plus 6, which is 12. 12 greater than 12. It's not, they're the same, right? So that one doesn't work, so this one is also not a triangle. Which should also make sense, because if I have a 12-centimeter length and I've got two 6s to put on it, those two 6s will stack perfectly on it and close, but if you start to make an angle, they're going to kind of pull apart. Right, so, and the last one, 9, 5, and 11. So if I take 9 plus 5, that's greater than 11, or 14 is greater than 11, which that works, right? And we could do that with any pair of them on this one. So 5 plus 11 would have to be greater than 9, which that's 16, which is greater than 9. And 9 plus 11 is definitely greater than 5, because both of them start greater than 5, right? So any two added together are greater than the third side, but really we only really have to check the two smallest ones to make sure that they're bigger than the biggest one. But so all of them work. So will this make a triangle? Yes, that'll make a triangle. All right, one last example here. The triangle has one side length of 8 centimeters and another of 17 centimeters. Describe the possible lengths of the third side. All right. So we got 8 and 17. So I know that that length of 8 plus some other number we don't know is going to have to be greater than the third side 17, right? Which if we solve that, we subtract the 8 from both sides, that'll give us that x is going to have to be greater than 9. And then on the other hand, 8 plus 17 is going to have to be greater than whatever the third side is, x. Which 8 plus 17 is 25. So 25 has to be greater than x, or if we flip that around so that the x is on the left side, I was going to say that x is less than 25. So the third side must be between those two numbers, between 9 and 25 centimeters. So if it gets bigger than 25, then 8 plus 17 is not going to work to make a triangle. And if it's smaller than 9, then that side plus the side that's 8 won't be bigger than 17. So the smallest side plus the third side that we don't know has to be bigger than the third side that we do know. And then the two sides we're given have to be bigger than the side we don't know. So questions there? Anybody?